We've spent a bit of time making our models' predictions more visual, which is very, very important for when you're communicating your work. I don't want you to think that just building a model and having an accuracy value like we've got up here is enough. Because at the end of the day, you can actually run this to get something like this in about 10 lines of code. But what really matters is how you're going to integrate your model's use and how you're going to communicate what it's actually doing to other people. Because remember, always bring yourself back to what the project goal is. What are we trying to do here with Dog Vision? So let's take our little visualization functions, and it'd be good if we could see more than just one at a time. So let's write some code to do that. We'll leave a little bit of text here. Now we've got some functions to help us visualize our predictions and evaluate our model. Let's check out a few. So what we can do is probably create a few subplots, and I want to get this image compared to its top 10 pred confidences. So that's what I'm going to do. Let's check out a few predictions and their different values. Nice and simple. So we want to go I multiplier. This will make sense in a second. So we'll keep it at 0 to begin with. And again, this is probably something we could also functionize. Maybe that's a little challenge to you. So we'll go number of rows, 3, numcols equals 2. So we're going to plot out a subplot that's got 3 rows, 2 columns, and the number of images total is just going to be num rows times numcols. And then we'll go plot.figure. We'll set the fig size. I've had a bit of playing around with this, so this might have to change depending on what your notebook is. Or actually, we could probably just go 10 times numcols and 5 times num rows. All right, so now we want for I in range num images. So 5 times 2, we're going to plot, or 3 times 2, sorry, we're going to plot 6 images total. Num images, we need a semicolon there. We want to create a subplot, plt.subplot, and it's going to have 2 rows, but it's going to have 2 times number of columns, and this will make sense once we plot it out. So 2 times I, this is the index we want to use. Now we want to go plot pred prediction probabilities is equal to, why did that go to a next line? Come on, Mart. Prediction probabilities equals predictions. And then we want to go, what else is after that? We need to pass it labels. So labels is our val labels. And then images equals val images. And then the n, so the number or the index of the image we want is I plus I multiplier. And I'm starting to realize how janky this code is, but that's all right, it's going to work. We could probably functionize this. Remember I set you a little challenge at the start of the video? Functionize this. That could be a cool series, functionize this. Someone just writes poor code and then someone turns it into a function. We go here, plot pred conf, prediction probabilities, predictions, and then we want to go labels equals val labels, because what we want to do is just compare our predictions to the truth labels. And then the n is going to be, again, I plus I multiplier. And then let's see what it looks like, plot.show. Hopefully this works. Hey, it's starting to come out. Remember, it might take a little while. Oh, that looks pretty terrible. How can we fix this? So it's kind of getting what we wanted, like an image with a title and then the top 10 prediction probability. So see here, Border Terrier, number 1, but it got it wrong. The true label was Cairn, or Can. I can't really pronounce that. We have a city in Australia called Cairns, which is spelt very like that. It has an S on the end. Let's fix this plot. We want plot tight layout should help us out. So tight layout is just basically like, hey, we're working with a subplot. Don't just plot them all over the place. Bring them together. Oh, you know why? I think this is broken because we're calling plot.show inside the for loop. So it's going to show a subplot every time it plots. Where are we going? Oh, there we go. Look at that. Oh, and our labels are cut off. This is where plot tight layout will help. So one last adjustment to fix up our plot. plt.tight layout. And we want to do hpad, so horizontal padding. So basically, like, take the padding along the horizontal axis and just give us a bit more space. Equals 1.0. And would you look at that? 4th time lucky. That's what it's all about, right? Trial and error. Trial and error. If in doubt, run the code. So what's happening here? We've got our image here. We've got Border Terrier, 22% Cairn. We can see, we just looked at this one. Let's look at this. Scotch Terrier. So we can see it's got a few other predictions here. It's overwhelmingly predicting Scotch Terrier. Oh, this one it got it wrong. Lakeland Terrier, and it's actually a blue tick. So wow, this is the fourth label. So it's overwhelmingly predicting Lakeland Terrier. What's a Lakeland Terrier? Look, I'm using underscores because that's what our labels have. Images. Okay. You can kind of see that. There's a fair bit going on in that image. I think that even might be a cat over there. Okay. Bellington Terrier. Yep, it's got that. Wow. It's got that one really right. That's amazing. Oh, now this. That is a beast prediction. 98%. Look at that, it just drops off. That's what's up. Okay, now let's change this to maybe, see the I multiplier is going to modify our N. So we want to try it. Let's just try the next 10 images. Oh, Irish Wolfhound, 34%, but it's actually a Yorkshire Terrier. Again, this is, you can start to see how this image is pretty hard. Because look how much is going on. We got not sure what that is in the background. We got 2 people here. But what's an Irish Wolfhound look like? Irish Wolfhound. Oh, big dog. Wow. Okay, you can almost... Oh, it's really clutching at straws to try and say that it's an Irish Wolfhound because look, it's even got 3 more predictions: Toy Poodle, Lakeland Terrier, Italian Greyhound before the actual true label. So this is really fun. This is predicted Cuvaz, but it's actually a Border Collie. And now you can see how it's probably got confused because there's another dog there. Whippet. Miniature Poodle, Standard Poodle. Look at that. How fancy is that? Oh, okay. So see here, the top 3 labels are all poodles, but it's a Standard Poodle when it's predicted a Miniature Poodle. Now, this is where a lot of evaluation machine learning models, this is what you got to remind yourself of. If a human classifier, like if we were looking at this image and if you knew dogs, I don't really know dogs except for like the 3 breeds that we've spoken about before, I would say that that's just a poodle. But there's actually multiple different kinds of poodles. So you got to give your model a little bit of leniency here and go, okay, if a human is going to get confused on predicting, a machine learning model is probably also going to get confused at some point. So let's do one more sample because this is just fun to look at dogs and look at our dog vision application coming together. Now remember, this is only trained on 1,000 total images. So hopefully we see a little bit of improvement when we train a full model. Look at that, that's a beast prediction. Golden Retriever, it's actually a flat-coated retriever. Cairn, yes. That's a great prediction there. So this is cool, right? This is really cool, visualizing what's going on. If we were to show this to someone else, we could explain to them, rather than just showing them a prediction probability array, we could start to explain to them what's happening. And if we were building our dog vision app, this is probably something we'd like it to display, and even something like this. Maybe looking a little bit cleaner. This is still a bit matplotlib spec in a Jupyter notebook. But this is a really important part of building a machine learning workflow. So here we are, evaluate the model. What we might move on to next, we might jump all over the place a bit. We might save and reload our trained model, because right now, if our Google Colab session decided to quit and we didn't save our model, we'd lose all of our predictions, so we'd have to retrain a model. So let's figure out in the next video, now that we've visualized some of our predictions, I could play around with this all day actually, let's figure out how to save our trained model and load a trained model in TensorFlow.